The Patriot MIM-104 is one of the most recognizable and widely deployed theater air defense systems in modern military history, built to detect, track, and defeat aircraft, cruise missiles, and ballistic threats. Developed in the late Cold War era and continuously upgraded since, Patriot combines phased array radar, an engagement control station, and interchangeable interceptors to create a layered networked shield. In this video, we'll unpack Patriot's origin story, core components, missile variants, tactical roles, combat record, recent upgrades, and how militaries use it today. Start with a brief history. Patriot began as a replacement for older systems in the 1970s and reached operational status in the early 1980s, evolving through multiple software and hardware blocks. Its first major combat trial came in the 1991 Gulf War, where Patriot batteries were tasked with defending against Iraqi Scud missiles and emerged as a headline system despite later debates over kill rates. At its core, a Patriot battery is a combined arms element, radar unit, engagement control station, power and communications vans, launchers, and the interceptor missiles themselves. The radar and fire control heart were long represented by the AN/MPQ-53 and the newer AN/MPQ-65 phased array radars, capable of simultaneous search, track, and guidance roles against many targets. That radar capability lets a single Patriot engagement cell perform detection, discrimination, tracking, and guidance without relying on separate sensors for each task. The Engagement Control Station, or ECS, acts as the human-machine interface. Operators assess tracks, assign priorities, and authorize launches, while automation helps manage engagement timelines. Launchers typically hold 4 or more interceptor missiles in vertical canisters. Modern launchers M903 support mixed loads of PAC-2 and PAC-3 missiles for flexible layering. Patriot supports 2 principal interceptor concepts: the PAC-2 family, which uses blast fragmentation warheads to damage or destroy incoming warheads, and the PAC-3 family, which uses hit-to-kill kinetic interceptors. PAC-2 is larger and uses a proximity-fused fragmentation warhead optimized against aircraft and larger missile bodies, while PAC-3 emphasizes agility and direct impact to neutralize warhead re-entry vehicles. The PAC-3 Missile Segment Enhancement MSE added a larger dual-pulse motor and improved control surfaces, extending range, speed, and maneuverability to better counter modern threats, because PAC-3 missiles are smaller and can be carried in larger numbers per launcher. A Patriot battery can concentrate more hit-to-kill interceptors on high-density raids. Patriot-S software and networked architecture make it more than a set of parts. Integrated battlefield links let Patriot cooperate with other sensors, like in TPY-2 radars and national air defense networks. That networked flexibility is central to modern Patriot employment. Commanders can fuse tracks from allied sensors and share a common air picture for more effective engagement decisions. Tactically, Patriot is often used to defend high-value assets: capital cities, critical infrastructure, troop concentrations, and air bases where survivability is essential. A single Patriot battery is resource-intensive. It requires a trained crew, logistical support, spare interceptors, and protected sites for radars that can be targeted by adversaries. The system also has mobility, though not as mobile as short-range SOMs. Patriot batteries can relocate and reemploy, complicating enemy targeting and reducing vulnerability to counter-battery strikes. Combat experience has shaped Patriot's doctrine. The Gulf War highlighted both successes and limits, pushing upgrades toward better discrimination, higher reliability, and improved interceptors. Later conflicts and regional deployments, from the Middle East to Eastern Europe, provided more operational lessons about saturation attacks, decoys, and the need for layered defenses. More recently, Patriot batteries have been sent to high-threat theaters where adversaries use advanced cruise and ballistic missiles, and the system's role in integrated air and missile defense has expanded. Patriot's strengths include long detection ranges, multi-track capacity, upgradable software, and the option to field both fragmentation and hit-to-kill interceptors in the same architecture. Its weaknesses are predictable too: high cost per interceptor, logistical footprint, radar vulnerability if not well protected, and the challenge of defeating massive saturation or very low observable threats on its own. Layering is the answer. Patriot is most effective when combined with lower-tier, short-range systems and upper-tier sensors or interceptors to create overlapping coverage. Modern upgrades focus on better radars, improved battle management software, and integration with new sensors like LTA-MDS and IBCS to allow cross-system tasking and concentric defense layers. Manufacturers and services continuously test Patriot in live-fire events to validate upgrades and improve algorithms that guide interceptors against maneuverable targets. Beyond hardware, Patriot's combat effectiveness depends on training, rules of engagement, maintenance, and supply of interceptors. Shortages or degraded training can reduce real-world performance. We should also talk numbers. A typical Patriot battery may have 1 radar, 1 ECS, 6 launchers, and a magazine of interceptors. Multiple batteries are needed to defend an entire region or theater. Countries operate Patriot in different configurations, balancing Pac-2 and Pac-3 inventories based on perceived threat types, whether primarily cruise missiles, aircraft, or ballistic missiles. Patriot is a national symbol of deterrence. Deploying it signals to adversaries that an air attack will face sophistication, layered resistance, and raises the political price of strikes. Operational challenges include the need to conceal and harden radars, move launchers unpredictably, and coordinate with allied assets to reduce the risk of losing a battery to long-range strikes. Adversaries have adapted by using salvo tactics, decoys, and mixed attacks that seek to overwhelm a single-point defense, again, underscoring why layered. Redundant systems are critical. In some theaters, Patriot batteries became high-value targets, requiring protective measures like camouflage, dispersal, and active defense to avoid preemptive strikes. From a logistics view, PAC-3 interceptors are expensive, but offer high kill probability per shot. Commanders must manage expenditure rates during prolonged campaigns. Industrial capacity matters too, ramping up Pac-3 production or replacing expended. Interceptors require stable manufacturing lines and international supply cooperation. Looking forward, Patriot's legacy architecture is being modernized to interface with next-generation radars and battle management systems, preserving its role as a core mid-tier defender in multi-domain defense. For viewers wanting to understand technical details, Pac-3 uses hit-to-kill kinetic impact, while Pac-2 relies on fragmentation blast. These choices reflect trade-offs between mass and precision. Patriot's radar performs search, track, and engagement simultaneously because its phased array can form many beams and dedicate them to separate tasks in parallel. Training a Patriot crew takes months. Radar operators, engagement officers, and launcher teams must work in sync under complex rules of engagement and high-tempo conditions. When watching news about Patriot deployments, note the context. Sending Patriots is both a military and political signal, often meant to reassure allies and deter further escalation. If you're making a video edit, show diagrams of beacon tracks, split screens of Pac-2 versus PAC-3 intercept profiles, and archival footage from Gulf War tests to illustrate evolution. To wrap up, Patriot is not a silver bullet, but a powerful, adaptable system that remains central to many nations' air defense postures because of its flexibility and upgrade path. Its future will be shaped by integration, better networks, sensors, and lower-tier complements, rather than by any single hardware change. Thanks for watching this deep dive into the MIM-104 Patriot system. If you liked this breakdown, hit like, subscribe, and tell me whether you want a technical deep dive into Pac-3 MSE, radar theory, or Patriot tactics in modern conflicts. Sources and further reading are linked in the description so you can verify details and explore official datasheets, think tank analyses, and recent operational reporting.